So to clear the memory of the whole thing, you do second plus 712. That will clear the memory of the whole calculator. So that all the things that we did in my 3rd hour class are now gone from your calculator, which is good because they're not doing the same thing as you. Okay, but way back in Algebra 1, you learned how to graph an equation. Do you remember how to do that? Do you remember doing that in Algebra 1? Yes? No? Yes? Okay. So as a refresher, you go to y equals, which is right up here. We're using almost all of these buttons up here at the top today. So go to y equals, and then you can type in whatever equation it is that you're trying to graph. So today we're going to do quadratic applications, which are x squareds. So you're going to use the x button, which is next to the green alpha button. And then you can either raise it to the power of 2, or you can just hit this x squared button right here. And then hit enter. That puts your equation in there so that you can graph it. So once it's in there, you can hit the graph button. It actually shows you a picture of the graph. Okay, your calculator also shows you the table. If you do second graph, it'll show you a table of values forever and ever in both directions. So second graph shows you the table of values. Okay, you can adjust the window of your graph to show other areas that you can't see. So an X-min shows you how far to the left. X-max is how far to the right. The X scale, all that means is it tells you how often they're going to have a tick mark. So like right now, the X scale is 1, so that means there's 1 tick mark every, like between every unit. You can make that 5, you can make it 100, you can make it whatever you want to. So if you do numbers that are bigger, you don't have quite as many tick marks and it doesn't get as confusing. And then Y values, your minimum shows you the bottom of your graph. Y max shows you the top. And then there's also a Y scale right there. What we'll use the most today is the calculate menu, which is second trace. So if you do second trace, these first 5 are all the ones that you're going to want to know how to use. So that first option of value, that's your Y value when X equals to something. Okay, so if you need to figure out what your Y value is when X is 3.5, you can plug it in there. 0, that's going to find your x-intercept. The minimum is exactly what it sounds like. It's the minimum value. The maximum gives you the maximum point. And then intersect is what you use whenever you have more than one equation and you're trying to figure out where they cross. So if you have your sleeve of notes, there's a paper in there that shows you these. Okay, if you don't have your sleeve of notes, then I will try to find you one of these. Okay, but this explains everything that I just said. Okay. So really quick, I would write yourself some notes on here because we're going to use this often. So to graph an equation, you do y equals, and then hit the graph button. To adjust the window, you're going to hit the window button. And then I'm going to come over here and draw over here. And then as a reminder, over here is your X minimum To the right is your x max. Bottom is the y minimum, and the top is the y max. To look at the table of values for your graph, you do second graph. And then probably most important today is the calculate menu, which is found at second trace. So you did all of that in Algebra 1, but I know it's been a long time for some of you since you've had Algebra 1, which is okay. It's been a long time for me too. So our first thing we have here, any object that is thrown or launched into the air, such as a baseball, a basketball, a soccer ball, is a projectile. The general function that approximates the height in feet of a projectile on Earth after t seconds is this equation. This is just your general equation for our quadratic application problems we're going to be doing. So it's h of t, or your height, equals negative 16t squared plus v sub 0, which they call v naught. I don't know why, but that's what they call it, v naught t, plus h sub 0, which they call h naught, where v naught is your initial vertical velocity and h naught is your initial height. Initial meaning starting. So example 1, a soccer ball is kicked from ground level with an initial vertical velocity of 32 feet per second. After how many seconds will the ball hit the ground? So I'm going to write an equation by plugging in all of the things to this general equation up here. So I'm going to have h of t equals negative 16t squared plus, what's the initial vertical velocity?
32 feet per second.
Yep, so 32t plus h naught is your original height. What's our starting height? 0. It says from ground level, so that's a starting height of 0. If you write your equation and you don't put the plus 0 at the end, that's fine. Okay, I won't write it. Okay, but they're asking us, after how many seconds will the ball hit the ground? Okay, well, let's think about this. If I draw this in a graph, if I kick the soccer ball from ground level, it's going to go up for a little while, and then it's going to come back down and it's going to hit the ground, right? So I need to know when this point occurs, because that's when it's going to hit the ground. Okay, if I wanted to, I could plug in a height of 0 here and solve by hand, but I don't want to do that because I have a calculator and it's a word problem and I'm going to let the calculator do the work for me. All right, so in my calculator in y1, I'm going to type in my equation. You can't type t into your calculator, so we're going to do negative 16x squared plus 32x. And then we're going to graph it and see if we can find that value. So I'm going to type it into y equals negative 16x squared plus 32x. If you want to put that plus 0, you can, but you don't have to. Once my equation's in there, I'm going to hit graph. Okay, but does that graph look like the one I drew right here? It kind of does, but I can't see the top. And on my graph over here, I've got all this extra stuff around the sides that I don't need. So I'm going to go to the window, and I'm going to adjust some things. So over here on the left is my x minimum, and right now I'm at -10, but if x is talking about time, I'm not going to have negative time. So I'm not going to start at -10, I'm going to start at 0. The x max was fine. I had some extra over here, so I could change it to 5, but I don't have to. And then I'm going to leave the x scale at 1. The y minimum is talking about the height of the soccer ball. Am I going to have a negative height? No. So I'm going to start at 0 again. And then I couldn't see the top of my parabola up here, so that means I need to make this y max larger. Since I don't know what it is, I don't have any idea, I'm just going to guess something larger than 10, so I'm going to go with 25. So I've changed my window to have an x minimum of 0, x max of 5, a y minimum of 0, and a y max of 25. So now when I graph it, that looks a lot like the graph I drew over here when I was just thinking about what would happen. So now I've graphed it, but I'm trying to find this point over here, which I haven't done yet. But my calculator will do this for me. So I'm going to go to Second, Trace, that Calculate menu. And that second option right there says 0. But let's remember that 0 and solution and x-intercept, they all mean the same thing, right? So that's the option I want to choose, is I want to find the 0. So I'm going to choose the second option from that menu. And then it's going to start asking me some questions. So it's going to ask for a left bound and a right bound and guess. So what they're saying when you have left bound and right bound is your calculator can graph this parabola forever and ever in both directions until infinity, right? And so it's asking you to take that infinite amount of information and narrow it down. So they need you to take that giant parabola and they need you to cut it into the section that you're actually looking for, because it can calculate forever, but we don't want it to. We just specifically need this point right here. So a left bound and a right bound is telling your calculator to cut your graph to the left and to the right of the point that you need. So a left bound and a right bound. Okay, well, if you notice, my left bound is going to be to the left of my 0, which means it's going to be somewhere up here. So I'm going to use the left and right arrows till I see my cursor. It's hard to see right there, but it's a blinking cursor. And I need it to be somewhere to the left of my 0, somewhere to the left of my x-intercept, which is going to be anywhere up here. Okay, mine right now is at 1.489. Yours could be at 1.2. It can be anywhere to the left of that 0, because that's where you want to cut it off to the left. So once you get it somewhere, you hit enter, and it makes this little triangle up here at the top. And then down here, it's asking for the right bound. So now that we have a left bound, I need to find a right bound somewhere. Well, if I continue this forever and ever, it's going to continue underneath, right? So I need to find a right bound somewhere underneath the x-axis. So I'm going to use my right arrow arrow down, and it can be anywhere down here. Notice my y values are now negative, which is what I want them to be. Hit enter, and this time it gave me another arrow right here. So what this is showing me is that I've just taken my whole graph and I've cut it into just this section right here in between my two pins. Okay, it's going to ask you to guess. You don't have to guess. I don't know why they ask you that. And you'll hit enter, and now it gives you a 0. So it gives you an XY point. That is the 0, this point right here that we were looking for, that x-intercept. So I typed this into y1, then I did second trace 0, and then once I did that, I got the point to 0. So the coordinates of this point right here when it hits the ground are 2, 0. So that means my time is 2, my height is 0. So after how many seconds will the ball hit the ground? 2. So I'm going to write a sentence. The ball will hit the ground after 2 seconds. Okay, the hardest part about all of that is trying to get the left bound and the right bound. But it's really just trying to cut off your graph to be that one little section that you need it to look at. Okay, this next part right here says, what is the maximum height of the soccer ball, and how long does it take to reach that maximum height? So we're on the same soccer ball, the same equation, which is nice. It's going to be the same graph. Okay, and then we're going to use some common sense here. It's asking for the maximum, so that's going to be this point up here, right? Because that's the max of my parabola. So now I'm going to go to second trace, and which one of those options do I need? Maybe the one that says maximum. Okay, don't make it harder than it needs to be. Okay, again, it's asking for left bound and right bound. So again, they're telling you I have this entire parabola forever into infinity. I need to chunk it off and only look at that one section that they're asking for. So the left bound, I need to move it somewhere to the left of my maximum. So I'm going to move with my left arrow that cursor over until I'm somewhere on the left. You can make it really close up here. You can make it really far away. It does not matter as long as it's on the left side. Hit enter, and it's going to ask again for the right bound. So now we're going to the right of our maximum. So move your cursor somewhere over there. Hit enter. Again, it asks you to guess, but you don't have to. So hit enter again. My maximum is at the point 1.000016. Okay, you can round that to be the 0.116. So I found the max. Okay, if you're not good at remembering calculator steps, it's second trace maximum. So my maximum is the 0.116. 1 is talking about time. 16 is talking about height. So what is the maximum height of the soccer ball, and how long does it take to reach that?
second, 16.
Yep. So it takes the ball. One second to reach a max height of 16 feet. So if you have the calculator, let the calculator do the work for you. So much easier than doing it all by hand. Okay. Okay, our next example is talking about a stunt woman. So it says a stunt woman jumps, but we're going to say she falls. A stunt woman falls from a building 73 feet high and lands on an airbag that is 9 feet tall. Write an equation for her height above the ground h, where t is the time in seconds. Okay, so just like last time, I'm going to draw a picture of what this actually looks like so I can get it in my head before I try to graph it on my calculator. So we have this stunt woman. She's up here, 73 feet off the ground. And then she's going to fall. And if we don't catch her, then she's going to hit the ground right here. Right? But instead of hitting the ground, she gets to hit this airbag. And the airbag is 9 feet off the ground. So here in a minute when I graph it, that's what I want my graph to look like. I want to be able to see where she starts up here at 73 feet, and then where she falls, and then she's going to hit this 9-foot line. So if I'm going to write an equation for her height above ground, I'm going to use that general equation we had on the other side of this page. So h of t equals negative 16t squared. Do I have an initial vertical velocity if she's just falling? Nope, I don't. If she were jumping, then she would have one, but if she's just falling, I don't have an initial vertical velocity. So her velocity is 0. Again, if it's 0, you don't have to write it. And then what's her initial height? 73. So question A, how many seconds will the stunt woman fall before touching the airbag? So I'm trying to figure out how much time is between 0 when she starts and right here where she hits the airbag. So I'm trying to find the time in between there. So again, I'm going to let my calculator do the work for me. I have my equation for her, so I'm going to type that into y1. And when she falls, she's going to hit the airbag at 9 feet. Well, to get a horizontal line like this at 9 feet, that's just y equals 9. So y2, I'm going to let equal 9. So I have an equation for the stunt woman and an equation for the airbag. And I'm going to type those in. Okay, and then if I hit graph, this is still my window from last time, but I can't see the top. I can't see where she starts falling. So that's on my y-axis right here. So I want to make this taller so that I can see where she starts to fall. So I'm going to go to Window. Sorry. And I'm going to change this Y maximum. And what do I want to change it to? 80, something more than 73, right? So I could do 80, I could do 100, I could do 500, but that would be silly. That'd be too much, right? So if we change it to 80 and hit graph again, now you can see where she starts up here at 73 feet, and then she's falling, and then right here is where she's going to hit the airbag. Okay, so that point is going to happen where my parabola crosses or intersects with this horizontal line. So on my calculate menu, second trace, which one of those do I want? Intersect. We want the fifth one. So I'm going to do second trace intersect. And then again, it's going to ask me some questions. Okay, but just think about what it's saying. It's saying first curve question mark. And then up here it says y1 equals, and then it's all the stuff we typed into y1. Well, that is our first curve. That's the stunt woman. So we want to use that one. So hit enter. The second curve is y2, which is 9. We did that correctly. Enter. Again, you can guess, but you don't have to. So it shows you the intersection is the point 2, 9. So the point right here where they cross is the point 2, 9. 2 is talking about time. 9 is talking about height. So the question's asking, after how many seconds will the stunt woman fall before touching the airbag? So how many seconds does she fall? Yep, 2 seconds. She will fall for 2 seconds before hitting the airbag. And again, the calculator did all that for us, which was so nice. Okay, part B, suppose the stunt woman jumps from a building that is half as tall. Will she be in the air for half as long? Okay, well, let's think about that. That's going to change my picture because she's not starting at 73 feet anymore. She's going to start from half of that, right? 73 divided by 2. Yep. So she's actually going to start right here from 36.5 feet. And then she's going to fall. And she's going to hit the airbag at some point. So do you think she's going to be in the air for half as long? You think so? All right. Well, let's see. Just guessing. Okay, how's that going to change my equation? Yep, the only thing that's going to change is I'm going to take this 73 and I'm going to change it to a 36.5. So I'm going to let y1 be negative 16x squared plus 36.5. I'm going to keep y2 at 9 because the airbag did not change. And again, I'm going to find the intersection of these two graphs. So go ahead and try that on your calculator. fix y1, and then find the intersect. Okay, did you get an intersect of 1.39? So did she fall for half as long? No. So no, because she will fall for 1.3 seconds, which is not half of 2. Okay, so pretty much anytime they're going to ask you when do they reach a certain height or something like that, you're going to put the second height in a y2, your equation in y1, and find the intersect. They're asking you for when two things cross, or if when it's going to hit a certain height. That's going to be an intersect question. All right, example 3 says find the dimensions of the rectangle. It is not asking you to tell me that the length is x plus 4 and the height is x minus 2. They're asking you to solve for x and then find the dimensions. Okay. So what do we know about this rectangle besides the x plus 4 and the x minus 2? Yep. Yep, the area is 96 meters squared. And how do you find the area of a rectangle? Yep. So area is length times width. And in this case, our area is 96. Our length is x plus 4. And our width is x minus 2. Okay, so we could multiply this out, set it equal to 0, use the quadratic formula, solve for x, and do all of that work. Do we want to do that, or do we want to let the calculator do it for us? Let's let the calculator do it. I don't want to use the quadratic formula if I don't have to. All right. So the way I'm going to do this is I'm going to do two equations because this is going to equal that at some point. So I'm going to set y1 equal to 96. And I'm going to let y2 equal the right side of the equation. You can leave it just like this. You do not have to multiply it out to type it into your calculator. Leave it in the parentheses and type it in exactly like it looks. So I have two equations. I'm going to do just like I did on the last question, where I find the intersect between those two. So I'm going to go into y equals. In y1, I'm going to put 96. In y2, I'm going to use the parentheses on the calculator to do x plus 4 times x minus 2. And then I'm going to hit graph. But it does not show me those two things. So that means I need to fix my window. So I'm going to go to window. Okay, well my x maximum is 5. That's really small. So I'm going to make that like 15. Totally guessing. I don't remember what the answer is. Okay. The y maximum is only 86, but it's only 80. I need it to be at least 96. So I'm going to make it 100. And then I'm going to try and graph it again. Now you can see where they cross. So I'm going to go back to my calculate menu, second trace. I want the intersection. First curve, second curve, and guess. And it gives me an intersection at 9.296. So I have an x value of 9.2 and an area of 96. And I need to find the dimensions of my rectangle. So that means I need to take my x value of 9.2 and plug it in for both the length and the width. So I'm going to have 9.2 plus 4 to get 13.2 meters. 9.2 minus 2 to get 7.2 meters. So the dimensions of the rectangle are 13.2 meters by 7.2 meters. Okay, I don't like example 4 because they don't tell you how tall the friend is and it's kind of weird. So we're actually not going to do example 4. Okay, and that is it. That is quadratic applications. So all the things you need are in that calculate menu, which is at second trace. Second trace. So this page is going to fold and go in on page 52 in your notebook. All the other things in your notebook can go on page 53. I'll show you what mine looks like. Yours doesn't have to look just like mine. But I want to clarify that on Wednesday I won't see you because it's the digital learning day. So if you are a junior or a senior And your assignment for that day will be a Google form that you have to fill out saying that you were present for the day. And then your assignment, I'm going to post the review for the test, and I'm going to tell you to pick a certain number of questions. I haven't decided how many yet, but I'm going to say pick maybe 10 questions off the review, solve them, take a picture of your work, and upload it. Okay, that's the work for Wednesday. Then on Friday, we will review together in class, and then your test will be on Tuesday. All right, so everybody gets to review, whether you get to review on your own Wednesday or not. And then we'll all review together on Friday. And since there's only 3 minutes left in class and you need the calculator to do your homework, on Friday, we will take time to do the 5 homework questions that go with this and turn that in, and then spend the rest of the time on the review. Does that make sense? So everybody understands you have a test on Friday. Nope, a test on Tuesday. Not tomorrow, Tuesday, but next Tuesday. Okay? Also, if you're missing stuff, not you, if the rest of you are missing stuff, it's due on test day. After test day, I'm not going to take it because having to go back and take homework from months ago just gets too much, and I can't hardly keep up with what I got now. Okay? So anything late will be half credit. If it's in eSchool already, it'll be late. If it's not in eSchool, that means I haven't graded it yet. Okay, so anything that you feel like you're going to turn in needs to be in by the test date. Any questions on that?
So there's no homework that day?
No homework tonight.